Okay. You should have done this. Number one. Well, yeah, just put down the formula you're using when you do this, okay? So from 2 to 8. Oh, yeah. Give me a second. Connect. Let's see if this works. Connect. Is it working? Yeah. All right. You're going to do V of 8 minus V of 2 over, that's a 2, 8 minus 2, which is something. Negative 120 minus 100, negative 220. It sure is negative 110 over 3. And the units on that are going to be meters per minute squared. Easy peasy. Real quick, while we're thinking about it, there are two ways to find the average acceleration. One of them is the average rate of change of velocity, which is what we just used, right? The other way to find the average acceleration is to find the average value of acceleration. Okay? There's two formulas. You should use the one that you have the function for. Since we had velocity, we use the average rate of change of velocity. But if we had acceleration, we would do the average value of acceleration. Okay? They both spit out the same exact number. Okay. B, do the data in the table support that the velocity has to be negative 100 meters per minute at some time between 5 and 8? And you're going to say, heck yeah, it does. Because it goes from 40 to negative 120. And we know that V is continuous because it's differentiable. So we got to say all that crap. So if I were you, I'd start with that. V of t is differentiable and thus, I like to say thus, continuous. Sound good? You're going to write because V of, I forget what we're doing, an 8 and 5. Yep. V of 8 is less than, well, write what it equals. That's always good to do. Is negative 120, which is less than negative 100, which is less than V of 5, which is equal to 40. So we show it goes from above to below. Yes, ma'am.
If you don't write out what it equals to in general.
I don't know. Sometimes they throw a point at you. You put the value. You know, anytime you calculate something, even from a table, you should put, like, if you're going to say, hey, this is less than this, put the actual number down. Okay? If you can find it. Sometimes they set up questions where you can't find the value. Okay? But they're like kind of weird. You should definitely have V of 8 is less than negative 100, which is less than V of 5. Or you can write it backwards. You can write V of 5 is greater than negative 100 is greater than V of 8. That's fine. That's the same thing. That's an 8. Okay? So we said it's continuous. We know it goes from above to below negative 100, right? Greater than the less than. So by IVT, which you are allowed to abbreviate. You are not allowed to abbreviate average rate of change. Don't say AROC. Nobody does that. That's just us. Okay? You're all weird. IVT and MVT are okay. So by IVT, V of, and you can write this several different ways. You can write V of t has to equal negative 100, but it doesn't equal it the whole time. So you got to say something like this. For some t value, okay, or at least once on the interval 5 to. Easy enough. You don't have to write a ton. Use those inequalities, okay? Use the notation I'm using. All right. C says, at 2, train A is at 300 meters east of Origin Station. What a good name for a station. It's moving east. Okay? Write an expression involving integral that gives a position, and then use trapezoid sum to approximate it. So our position is most definitely, I don't know what you want to call it. I'm just going to call it x. X of t is definitely equal to 300 plus the integral from 2 to t. Oh, so, okay. A couple weird things I just did. I like to put x in this integral, but I've called my stupid position thing x. So I can't use x again. So I could change the position to a different letter, like p, or I can just use a different letter in my integral, but I'll put x's in here. It's okay? Yeah. Well, what? Oh, well, I'm just writing p of t. Oh, did they say specifically a 12? Yeah. Right expression gives position of train A in meters. Oh, at time 12. You're absolutely correct. So then you just put a 12 up here. Cool. So you don't even need to write P of 12. You can just write this part here. This is what they're looking for. And since I don't have a T in my integral, you can put T's in the V of T dt now too as well. All right. But regardless, you're going to say that that is approximately equal to 300 plus, we're going to do trapezoids here. My first trapezoid from 2 to 5, so it's 1/2, a height of 3, and the bases are 140. Anybody confused about that one? Remember that, cool, it's 1/2 the height, base 1 plus base 2, and the bases are the y values at the endpoints. Remember, these are these trapezoids like this. Okay, base 1, base 2. Plus 1/2 times the height on the next one is 3. And the values are 40 plus negative 120. Plus 1/2 a height of 4 times negative 120 plus negative 150. That should be a big bracket. Are we good? What are you guys doing? A waffle? This waffle's got way too many little dimples in it, man. What kind of waffle should we get? It was like micro. What do they call the dimples in a waffle?
Divots.
Divots? Waffle divots? What? Nooks and crannies? That's like an English muffin. Anyway, back to this video. What is this? 70 times 3 is 210. I'm just doing this out, kids. What's that? Negative 80, 40, negative 120. If I mess up, please let me know. What's that? Negative 270 times 2 is negative 540. Does that sound good? Okay. These two together make 510, right? I'm going to subtract off negative 540, which makes it, or add negative 540. Negative 30 plus negative 120 is negative 150. Is that okay? All that means is what? Remember, it started out east, now it is west of the station. Approximately 150. What are units on this? Meters? Meters. And it specifically says, that's it, right? Then was there anything else? Cool. Yo. Yes. Whatever you put here is going to go here. Does that make sense? Since t is our variable in this situation, yeah, t should be that. Okay. All right. And last but not least, there's a second train. It gives us its velocity. So again, you're going to notice a lot of these questions where they give you a table, somewhere down the line they introduce an actual function. All right? That's what they're doing here. Find the rate in meters at which the distance between train A and train B is changing at time t equals 2. Yo, that's crazy. Luckily for us, I know that the distance between them, you guys with me here? Between train A and train B should just be the position of train A minus the position of train B, true? That's the distance between them, which means the rate of change of the distance between them is just V of A minus V of B. Is that okay? No, is it? I thought I said west. Never mind, I'm a dumb. Forget that. I can't edit my video. That was a test. You passed. Thank you. This is a related rates question. Thank you. Okay. At time 2, yeah. Train A, here's origin station, right? Train A is out here somewhere to the east. Is that right? It's way out here to the east, and we know it's headed this way. The other station is north and headed north, or it could be south, but I don't know. It's up here somewhere. And its distance from origin station is either growing or shrinking. I'm not sure yet. Does that make sense? What's the distance between them? With the distance between them, we're going to know how fast that distance is changing. What's up? Oh, this is between them is 500, but they want to know how fast is it changing, right? Cool. So we have A, we have B. Those are the lengths, like the distances they are. And we have this distance here, C. We know how fast is C changing. So all this is a Pythagorean theorem related race question, which we've done a zillion of. Everybody, okay, you remember doing these? We're going to do an A squared plus B squared is C squared. And we're going to derive that with respect to time. Okay? So that's going to give us 2A dA dt plus 2B dB dt is 2C dC dt. Remember we said you can get all these variables, pick out the one they're trying to get you to find. The rate of change of the distance between them, which is dC dt. Which means in order for me to find this, I need to know every other value of these variables. There's 5 variables here. There's A, which is just the position of train A. There's dA dt, which is how fast its position is changing, or its velocity. Okay? There's B, the position of B, and there's how fast B is changing, which is its velocity again. Okay? And there's C, which is what C happens to be. They tell us all this information in this question. We don't have to do too much work here. We know at this point in time, they tell us it's somewhere back here. Yeah, at time 2, A is 300 meters away from the station. You all see that? That was back in question B. Cool? So A is 300 at this point in time, and its rate of change is positive 100 because it's moving away from the station. Everybody with me where these numbers are coming from?
Can you see what 100 is coming from?
Yeah, the 100 is coming from that table. Look at this table. At time 2, train A has a velocity of 100. And it's positive, which means it's moving this way away from origin station. Make sense? B, they tell me, second train is 400 meters north. And its velocity we have to find by plugging into its velocity equation. And we need to know how fast this dB dt, or how fast B is changing. But that's just its velocity, so we got to put a 2 in there. Cool? So whatever goes right here has to be the velocity of B at time 2. We're good? A little tricky. You put a 2 in there, you get negative 5 times 4. I wrote a 4. Plus 60 times 2, it's 120. Plus 25. So that happens to be 125. They gave you that equation in part D. It says V sub B. That's the velocity of B, which means that's how fast the distance of B is growing. Okay? It's 125. And that has to equal 2 times C, which you have to find here, but again, if one side of a right triangle is 300 and the other leg is 400, the hypotenuse has to be 500. dC dt. So now the only thing we don't know is that. Now we don't have a calculator for this particular question. So I said sometimes related race questions get a little bit out of hand with all the math. You should be simplifying each side out completely before you start doing this. What can I divide both sides by real quick? 2 definitely, 100 definitely, right? So let's do that. If we divide out a 2, that gets rid of this, this, and this. If we divide out a 100, we can just take this 100 away completely. This 400 just becomes a 4, and this 500 just becomes a 5. Okay? And we can technically divide everything by 5 as well. That makes that 300 a 60. That makes that 125 right here 25. And that makes the other side dC dt. So it's 100 plus 60, which happens to be 160. And since it's the rate of change of a length in this question, it's technically the velocity of, it's not really a velocity because nothing's moving along here, but it's the rate of change of the distance between them. So it has to be a meters per minute. Okay?